Hello. In this video, I'm going to be demonstrating the use of multi-factor key derivation to build a centralized password management application. One of the most important features of multi-factor key derivation is the ability to construct and cryptographically enforce arbitrarily complex key derivation policies. The demo application uses the policy seen here. During normal authentication, a password and TOTP second factor can be used to derive the key. But if either factor is lost, the key can also be recovered by the user using an email along with security questions or a recovery code. While this is the structure we chose for the demo application, with MFKDF it can really be anything. And importantly, this enforcement is all done trustlessly on the client side without requiring any server to store a master key or even shares of a key. Okay, let's see it in action. I'm going to start by creating an account with my name and email, clicking the link to confirm, and creating a password. I'm going to answer a few security questions, set up TOTP as my second factor, and write down my recovery code. There we go. The key setup process executed in under a second, and we can see that here with MFKDF, we get a key that is about 1,000,000 times stronger than a password-derived key. In this case, it takes the crack time from 4 months to over 300,000 years. All that's left to do is to store a few secrets, which will be end-to-end encrypted with my multi-factor derived key. So these secrets will now essentially be encrypted with all of my authentication factors, including my secondary factors, rather than just being encrypted with a master password alone. Alright, I'll sign out. And now before I sign back in, I want to discuss how authentication actually works with MFKDF. You see, normally, users directly present their authentication factors to the server to log in. But this requires some level of trust because the server could theoretically use these same factors to derive your key and decrypt any stored secrets. So with MFKDF, users actually just use the key itself to authenticate using a key-based authentication protocol. And because the key can only be derived using a valid set of factors per the policy, using the key to authenticate implicitly proves that some valid set of factors has been presented by the user, or else they wouldn't have been able to derive the key. Okay, proceeding now with the login, I use my password and Google Authenticator code as normal. In fact, as a user, I would have no idea at all that MFKDF is actually being used behind the scenes. And once again, it takes less than a second to derive a key. Now, I get the option to remember the device, which I'll accept. Behind the scenes, what's essentially happening is that the TOTP factor is being replaced by a TOTP or device factor. So I can now skip 2FA if I'm on a known device. In MFKDF, this is called factor persistence. Back at the dashboard, my secrets are exactly where I left them, decrypted upon login with my multi-factor derived key. Let me log out one last time to showcase the recovery process. Let's say, for example, that I forgot my password. I'll get an email with a one-time code, and then I can use either security questions or a recovery code to recover my account. I can then change my password to something new. Behind the scenes, I'm basically using this combination of factors to recover the key, and then I'm using an MFKDF feature called reconstitution to change the password factor while keeping the same key so I don't lose the ability to decrypt all my previously stored secrets. Once again, none of this is evident to the user who just thinks they're performing a standard account recovery process. But that's about it for the demo, and I encourage you to try it out for yourself at demo.mfkdf.com.